Hello and welcome to today's webinar, How to Achieve Full Stack Observability in Highly Distributed Environments. My name is Jordan and I'm in marketing here at Progress. Now I'm going to introduce you to today's presenter, Larry Goldman. Larry Goldman is the Director of Product Marketing for the Progress Application Experience portfolio, which includes the IT infrastructure management tools What's Up Gold, Kemp Loadmaster, and Flowmon. He is a seasoned product marketing leader with 20+ years experience in enterprise software, SaaS, services, and technical B2B marketing for global organizations. Now over to you, Larry.
Thanks, Jordan. And thank you all for joining us today to discuss network observability and observability platforms. Here's our agenda, where we'll start with a discussion of the challenges, or the why. We're going to move into the what, and finally we're going to touch on the how. I plan to keep this short and to the point, and we'll take questions at the end if there's time. There is no end to the challenges facing today's IT operations team. A core question would be, with all this rapid change we're seeing, how do we maintain visibility? The list you see on the side, it's never ending. These activities require complete network coverage. It's the only way that you can ensure smooth network operations. And because it's a rapidly changing digital world with the ongoing digital transformation, let's look at some of the numbers to represent that come from a recent report by the Enterprise Strategy Group, ESG. First of all, I don't think this is a surprise to anybody. Organizations, pretty much everyone, is moving to the public cloud. Also, about 86% of organizations that they surveyed use at least 2 or more of the public cloud services. So this growing complexity within their network and IT infrastructure. Here's an interesting one as well from the same survey. Organizations, 62% of organizations, still have less than 50% of their applications in the cloud. So they're moving to the cloud, but they're keeping a lot of the applications back, and eventually we'll be moving them over. But there's still a lot of work to be done in their digital transformation. But they have high hopes. 94% of these organizations state that they want to get deeper involved into edge computing. So what all of this is telling us is that your modern IT infrastructure is becoming an increasingly complicated mix of on-premise, public, and private cloud applications, devices, and environments. Distributed systems have a far higher number of interconnected parts, obviously, so the number and types of failure that can occur is also higher. Additionally, distributed systems are constantly updated, and every change can create a new type of failure. And there are just more unknown unknowns, as they say, in these distributed environments. So they obviously are more complex to manage, and that's why we're here and talking about network observability today. Because companies like yours have either begun to talk about investing in it or have already made some considerable investment into the platforms. We should note, though, that while it's a great idea to jump in, it's not so easy to implement. I found this study from LogDNA and the Harris Poll, and they went and interviewed a lot of professionals and said, how's it going? And the results were not very positive. For example, 74% of the companies they talked to said they're actually struggling, they use the word struggling, to achieve true observability. Okay, and this unhappy majority is dealing with a lot of the same issues. They report usability issues, they report collaboration issues, they report issues around how they deal with security events. It's not working as they had hoped. Another thing that's reported from this is that they're using a lot of tools, the tool sprawl that we hear about. 72% of these companies using 2 to 10 or more observability tools, and there's other studies that tend to show the average being between 10 and 15. The problem with using so many tools, obviously, one of them is the cost. So 2/3 of the organizations in the study said they're spending $100K or more annually on these tools, and the saddest part of all, I think, is that more than half of them indicate that they're not happy with those exact tools. So this, again, I think we're showing the challenge. We're showing here that it's not something that you just go into. It takes a lot of work. It takes the right platforms. And again, that's what we're going to be talking about. Clearly, getting to observability, just getting there can be a challenge. Now, I want to jump over to talking about what observability is a little bit, because there's so many things out there and so many ways that people are talking about it. If you run a simple Google search or attend an IT conference, or you visit an analyst website, you're going to see that everyone's talking about observability. It's a hot topic. All the major firms are publishing annual reports, and the vendors in the space have plenty to say as well. For those of you who are new to the concept, it's, I think, not difficult to get confused by what we read about conflicting definitions that these experts are presenting. Everyone's got their angle. Everyone has a little bit more of an emphasis. In some cases, the discussion can be kind of theoretical and less than practical. Some are high on jargon. I'm not a big fan of using a lot of jargon like that because it takes away from the quality of the content. So it really also depends on where you're coming from. Are you in network operations? You're looking to focus more on network observability. Or are you DevOps and you're interested in application monitoring across clouds? Or are you in security ops and you're interested in observability of traffic flows to detect potential security threats? We all come at this from a different angle. Maybe you're working in a team, hopefully, and collaborating, the NetDevSecOps, right? That would be another way that you're looking at lots of different aspects of it. So let's take a minute then to cover what we at Progress feel is the appropriate definition of observability. And if we go back to the beginning, this gentleman here, his name was Rudolf Emil Kalman. He was a Hungarian-American electrical engineer, an inventor, and he worked on control systems. And he's the one that coined in the 1960s the idea of observability. And here's his definition. It's very simple. Observability is the ability to measure the internal states of a system by examining its outputs. And I think a lot of people refer to this definition because it's pretty straightforward. In his case, he was using sensor data on control systems like for space and other engineering type products. But starting around the 2000s, we had more technical companies like Twitter that were gaining an interest in this idea. And engineers at these large tech companies were beginning to design ways to observe their complex systems, the systems of today. And so this is a definition then coming up that I like and that we're going to be using going forward in this presentation. I believe that this is the most complete and thoughtful definition that I've seen, and I've seen quite a lot of them. It comes from an EMA research report on network observability that was created after a year of research and conversations with hundreds of network professionals. So I think it was quite well thought out. I'm going to read it simply because I want to emphasize, I put the green italic emphasis in there. Network observability, it's a network monitoring system, and we'll be talking about network monitoring, that collects a complete and diverse set of network data, so comprehensive data, to provide deep visibility and actionable insights, not just insights, but actionable ones into both the current and the future states of the network. And that's a very important point that we'll be talking about as well, understanding the future state of your network. And actionable insights include how the performance of your network, the performance of your applications, the security of your network, as well as that critical end user experience. So I believe that this really does capture a very practical, usable framework for what network observability should be. And you can see why observability is important. It gives you greater control over complex systems because while simple systems have fewer moving parts, they're easier to manage. But the complexity, as we were talking about earlier, the complexity that we're growing towards, that everyone has to grow towards to keep up, to compete, to continue to do the work that we need to do on the technical infrastructure side, it can't be held back. And so the metrics like the monitoring CPUs and memory and databases and networking conditions that used to be merely adequate to help, they're no longer that. For greater control and complete network coverage, you need end-to-end visibility. Still, a definition is good, but let's look at how the tech's evolved to get us where we are today. One way is to focus on the difference between traditional monitoring, understanding the state of the ecosystem, and network observability. So monitoring tracks the overall health of the application. It aggregates data on how the system's performing in terms of things like access speeds, connectivity, downtime, and bottlenecks. It's especially good at alerting and for tracking and helping to analyze long-term trends. When it comes to the evolution, I think that there's roughly 4 stages. Stage 1 was no monitoring, right? Back in the day, there weren't tools. Things broke, we were lucky if we could fix them. Or maybe because the networks were so simple, it was much easier to identify. But the complexity, as we see, is growing. And so that brought on simple monitoring, much more of a manual process, things like sending out pings, answering simple questions like just, is the system connected? That was a great first step. As things advanced, we got into more comprehensive monitoring. This becomes automated. We start to get context. We start to be able to narrow down to figure where the root cause is for issues that occur within the network. And we can start to ask deeper questions like, is the system giving us the right response when we make a request? And finally, we build up to our topic of today, network observability. And this gets far more complex. Multi-service app support, we're looking at dependencies, we're looking at all different kinds of data. We're also optimizing it for that ephemeral environment that's always changing and growing as we add more services, as we add more clouds and so forth. And the quality of the questions, once again, goes a level deeper. When can an issue develop? Does it matter? I think another way to look at this as well is this progression, this evolution, is to look at the axes of this. And the first axis you can see as we've been moving from low context questions, low context data, and manual processes up to high context and automation. Another axis would be how we work, right? We're going from very reactive, oh, something's broken. Somebody just called me and told me it's broken. I got to figure out what it is first, and then I got to fix it. Going up then through becoming more proactive. Hey, I'm seeing a problem. Nobody knows about it yet. I'm going to fix it. All's well. And then moving into, with network observability, this predictive sense. Now, observability and monitoring complement each other, with each one is serving a different purpose. So monitors telling you when something's wrong. Observability enables you to understand why it happened, as well as what might happen in the future. And that's because observability is drilling down into the cause of failures to enable that deeper root cause analysis. It's looking at the dependencies across the changing and distributed environments. Now, a final point I want to make here before we go too much further is simply that I want you to remember that observability can only be done if you build the right stack in such a way that you can access the data you need. You have to build your networks to be observable. And that's the basic state of it. So that's the evolution. Let's talk about the types of data that are collected in this. You can see a whole list here, everything from network performance and bandwidth consumption, and that's across the entire network, to things like wireless, collecting log data, collecting configuration and application health data, all different kinds of data from your devices, and trace data as well for applications. So these are all different kinds of data that are used, and it needs to be collected from on-prem, cloud-based services, co-location centers, and remote locations. Plus, this all needs to be contextualized with the other data to deliver insights. And that's really what these tools are doing. They're helping us with the context, looking at the dependencies. It gets more complex. The tools grow to encompass and handle that complexity. We've talked about metrics a little bit. So what are we measuring from that data that we just talked about? Here's a sample of some of the kinds of metrics you can and should capture for observability. And this is just a short list, right? But these are the kinds of KPIs that help you quantify performance. They also help you to set alerts when a system's down or when load balancers reach capacity. And they help you to monitor events for anomalous activities such as security breaches. The best part is that when it's done correctly, network observability has been shown to be of substantial benefit to the business. And that has to be on our minds as well. So let's talk about that. Again, going back to the research online, there's plenty of it. I looked for great recent examples of business benefits for this. And you can take this to your boss and you can talk about it and say, look at these great things. The first one would be in terms of visibility, right? Much better visibility. And then that should be obvious in the term observability. But when they do studies and they talk to lots and lots of organizations that are doing this, they see great numbers around the improvement in the visibility around application performance, around the visibility into the security posture, as well as into the clouds and that distributed infrastructure, that hybrid cloud infrastructure as well. So visibility is a big benefit. Another benefit, really speed and cost savings. In this study, they looked at people who are leaders, but also people who are beginners working on network observability. And the leaders reported a 69% faster mean time to repair or mean time to resolution, whichever you choose, and that is amazing. They also showed tremendous cost savings. The more experienced an organization was, the more it was able to save against very costly downtime for their organization. So a benefit there. And finally, let's talk about the experience of people and about the security of our systems. It does strengthen cybersecurity posture, and it's been shown that it increases the ability for different teams to collaborate because usually they're working with the same deep information. Productivity is up because of automation, and the end user, whether that's a customer or an employee, they have an improved digital experience or application experience. So plenty of business benefits for network observability. So I want to move on now to the observability platform. Let's pause for a second and think about that cautionary phrase. Be careful what you wish for. The ESG has done a number of studies, and in this one, I thought it was very interesting. If you look at the numbers, you can see that 99% of the organizations they talk to believe that end-to-end visibility, by which they mean observability, is either important or very important. That people they just get it. They want it, they understand it. Maybe they haven't implemented it yet, but this is the direction that forward-thinking IT and operations groups are going. ESG also ran a survey to determine what organizations actually want from a solution. So it's one thing to say, hey, we want to go in this direction. It's another thing to say, well, how do you envision that? So they found that 20% of the organizations that they talked to, they wanted monitoring alerts and information, but they just wanted to do their own analysis and control solution, which I think a lot of people are moving towards today. And that would go, if you think back to the evolution that we talked about, that would probably be simple monitoring, more likely the comprehensive monitoring that we talked about. But it's not that definition of network observability. So what those people are asking for, they're maybe confusing the terms of monitoring with observability. But 59%, almost 6 in 10 of the respondents are thinking about observability as we've been talking about it. They want the management software to provide alerts and serve as a recommendation engine that could use based on learned behavior from automated real-time or historic data analysis. So they're getting that deep, rich data and looking at the dependencies as we've been talking about. But those 6 out of 10 still want the staff to be responsible for implementation and execution. Now, if you read some of the analyst reports, the analysts really would like to go where the last remaining 21% of respondents would go, which is to move into management software that does it all. It automatically detects, it analyzes, it recommends, applies the changes as needed, and then the staff can review those changes and maybe make their own changes in, but really the software is doing it all for you. And I think what ESG found really was that people want to know more, they want to see more, but they're not necessarily comfortable right now with giving too much control to systems. And I'd keep an eye on that, see how that changes going into the future. But really, I think there is an increased demand, but as we see, there's no agreement still on exactly what a platform should do and how much control should be ceded to automation and machine learning. But there are the basics, right? And we've already touched on a number of these, collecting that deep granular data from throughout the network, tracking it so you have comprehensive dashboards, you have materials that you can work with, being able to automatically detect and fix issues to a certain extent within this ever-changing and complex environment. Looking at applications and systems to help maintain the SLAs, to help maintain uptime, and getting those reports. And finally, the ability to look, because you're looking so intently at the network, the ability to use that to increase and improve your security posture. So platforms can be delivered in 3 different models. There's a virtual appliance, which can be deployed in public clouds, private clouds, or other on-premise infrastructure. And the performance there for virtual appliances depends on the infrastructure itself and the connectivity of the network. A second way would be a physical appliance. And we here at Progress, we have both virtual and physical for some of our solutions. This tool requires 1 or more specialized network hardware units to be installed on the customer's network. It's the least flexible method, but it also offers the most control. And finally, software as a service. I think we're all thinking going in that direction. The tool can be accessed directly through a web portal. But there are some downsides here too. It might not meet your security requirements or have the level of complexity that you require for your complex distributed networks. No product will offer you 100% observability. It's just the nature of things. In a study by EMA called The State of Network Operations, the authors examined the extent to which network operations teams could be proactive with network trouble. So they said, you're doing observability, how's it working? And they found that a majority of the teams claimed to proactively detect at least 80% of the problems before they impacted the business. It's good, right? A little less, about half of them could proactively remediate at least 80 of the problems. So 100% of observability, that's an amazing goal, but certainly, especially as you start, don't expect that it's going to be able to do everything for you. There's a learning curve, there's growth, there's building, and even the best practitioners out there are saying that they don't always get it right. So let's talk selection. As you look at the list below, you'll see that many of the features we've discussed aren't there, like real-time data, discovering and mapping assets, offering visibility across most types of network infrastructure. That's because those are just becoming the norm. Those are the table stakes. You should be in this for the long term, though, so it helps to focus on the robustness of the platform and the vendor, and that platform could include multiple tools. Once again, the Enterprise Strategy Group, who we've worked with, has some recommendations, and they're talking about 8 different characteristics that you ought to think about, again, for the long term. The first being end-to-end support, and this extends from the application to the end user, regardless of where that application or user is located. The second would be support for heterogeneous network environments. Your environment is heterogeneous. You've got a lot of different logos, a lot of different brands of different devices out there, and the system needs to be able to collect and correlate from them all. And for those in multiple public clouds, this capability be especially important. The collection of metrics, events, logs, and network traces, we've talked about this a couple times. You have to be able to collect as much data as possible from the network devices and traffic in order to accelerate problem identification and resolution. Support for application level monitoring. In the event of an outage or degradation of service for your applications, you have to have the ability to correlate that application traffic to specific network environments to speed and optimize the resolution of the problem. The ability to enhance security posture as well. Highly distributed environments, they naturally represent a much larger attack surface and greater risk to the business. Once a threat actor gets past traditional perimeter security and is inside your network, you need to use the data collected from the network to help detect anomalous traffic, that footprint that they leave, because they can be in there, they can be hiding, but they will leave footprints, and be able to take immediate action from what you're able to detect. Centralized management is a key to an observability platform. You need to drive operational efficiency and take advantage of a single management console, and that requires instrumentation and that the components that you have are able to speak the same language. We've mentioned AI a little bit, artificial intelligence and automation. Intelligent systems are required to manage the ever-changing and expanding network that we've been talking about. When considering a platform, you need to understand the level of intelligence and automation that's currently available in an option, as well as determine what will be available in the near future. Because a lot of programs are really just beginning to experiment with that. And as much as the analysts want to pull us into the future quickly because it's so exciting, companies have to develop these things carefully. They have to learn from it. And so a lot of organizations, a lot of vendors are moving in this direction and hoping to expand on this in the near future. Finally, a tight integration with other applications. It's imperative that network platforms are tightly integrated into your trouble ticketing, workflow systems, your other security and IT system tools. You need to be able to exchange data back and forth, and this is generally done by vendors that have published and support APIs to accelerate these integrations. And you should be asking questions about that as well, given what you need for your particular set of existing tools. Finally, what are the types of questions your team needs to answer based on your network complexity and distribution? Is tool sprawl an issue for your organization? How many observability tools do you have going across all of your teams? Cost has to be a factor. What can you afford? and what will allow you to scale when your observability tool budget increases. Think about that investment. Something that's scalable is very important. Many tools require intense customization, no matter what they claim on their website. Complex tools require that. It's just the nature of it. So look to see what must be manually customized, or do you have to purchase additional services from the vendor? That's good to know, especially how long is it going to take you to get this system up, tested, and running. Automation has to be a goal. How much can the tool do for your team before they need to step in? How much can the platform guide you or provide root cause analysis? And finally, it's very important to think, who's going to operate this? Is your team ready and skilled enough? We've discussed the challenges, the definition, the benefits, and what to look for in a platform. So let's finish up by briefly discussing the observability solutions we offer at Progress. Progress offers 3 tools designed to monitor and provide observability. They operate in a complementary manner and allow you to view your IT infrastructure from multiple vantage points. They're all solving for slightly different and slightly overlapping aspects of observability. The first, What's Up Gold, is for IT infrastructure monitoring. It analyzes logs, bandwidth, device status, hardware health, configurations, application health, and more, the type of data that we've spoken about, and it accesses the metrics we referenced so that op teams can apply that data to observability practices. And much of what this tool does can be automated, from detection to alerting to self-healing actions for devices and services wherever they are, on-premise or in a hybrid cloud network. Flowmon, in the middle, provides both network performance monitoring and rapid network detection and response through flow and packet analysis. Using machine learning and AI, which we have in Flowmon, it can examine and react to the anomalies in the traffic, performance, and network behavior. Then, through APIs, Flowmon can communicate with other devices to shut down a threat. We also offer Kemp Loadmaster, which balances application delivery and provides observability and insights into the security and health of applications, and therefore the vital end user experience. These can all operate in highly distributed environments, collect a complete and diverse set of network data, and provide deep visibility and actionable insights into the current and future state of your network. Here you can see the difference in What's Up Gold and Flowmon and what they can observe. You can see What's Up Gold in its dashboards, looking at all the different devices, looking throughout the network. Flowmon, looking at indicators of compromise, anomalies, looking at traffic and performance. They offer complementary solutions, and they're integrated as a platform through the What's Up Gold dashboard interface. The combined dashboard setup provides a centralized management point, we've talked about that, for all the network data, including that from Loadmaster, and faster diagnosis of device health, traffic performance, and security issues. In summary, when done properly, through the right platform that fits your budget, staffing, and network complexity, network observability will provide end-to-end visibility and complete network coverage. This allows you to understand the internal state of the system, and from that, you can determine what's not working correctly and why. And I hope, too, that you've also been able to pull some ideas as you're looking at systems, some of the selection ideas that have been proposed. Just to reiterate a few of the benefits again, it improves operational efficiency, network health, and security. Fosters collaboration. The different groups within your organization have the ability, using that single management interface and same language, to be able to begin to take their separate operations and begin to combine them and or at least begin to communicate more smartly. The customer, the users, have a better experience because you are solving issues prior to their being exposed out in the network. And finally, it allows you to keep pace with that complex, ever-changing, ever-evolving environment that is your IT infrastructure, and you can do that in one place. So I want to finish up here just to tell you how you can learn a little bit more. If you are looking for examples, we have plenty of case studies and videos on our website, progress.com. Also, you'll be receiving a link to this paper Afterwards, choosing the right network observability platform for highly distributed environments, kind of the inspiration for this talk. As well, we have a short video with Bob Laliberte of ESG and our own Jason Dover, and the two discuss how to choose an observability platform. It's a short video, it's very informative, and well worth your time. And with that, I'd like to hand it over to Jordan. I think we have some time for a few questions.
Thank you, Larry, for a wonderful presentation. We are going to go ahead and jump right into our questions. If you haven't done so already, you can now go ahead and add your questions to the questions panel. Kicking off with our first question, and this one came in earlier in the webinar. In the early study, the one with 74% not satisfied with their observability, what were the reasons and why did they want to exchange their tools?
Yeah, thanks, Jordan. That's a good question. I looked at so much research while we were preparing this, and that one in particular struck me because it's, if everyone's moving towards observability, as we talked about, why aren't they satisfied? And as you dig deeper into it, I think it came down to a number of issues. Number one, so the Harris poll did it, but it was also a vendor that specialized in log management software. So as you dug in, some of the dissatisfaction was around costs. I'm trying to remember. I think 2/3 were spending 100,000 K. 38% of the people that they surveyed were over $300,000 a year, and a lot of that had to do around data capture, data storage. So data. We talk about observability, collecting lots of different kinds of data. There probably are limits to how much data you want to get. For example, Flowmon, the tool I mentioned just now, as it's looking at network performance and traffic, it's looking at flow and it's retaining a lot less of the data because of the manner in which it's looking. And so it actually can save you on those data expenses. Other things that they brought forth in that study were the fact that some of the people that they surveyed were using so many tools that they weren't able to connect them properly, or there were use cases that were solved by one tool, but then not really adequately addressed by some of the other tools. So that tool sprawl that we talked about, those were some of the major pieces. I was curious too about that last piece about why they would want to change their tools, but when you dig into the study, it's less that they want to change their tools, it's just that they want them to communicate more into that platform type of approach that we talked about. I hope that was able to answer the question.
Excellent. Thank you, Larry. Another question came in here. Is there additional self-paced training for more in-depth use cases or configuration of our existing Flowmon instance?
Oh, that's a great question. Let me think on that for a minute. I am not a Flowmon specialist, but I do know that we're putting together some more self-paced demos and walkthroughs, as well as some how-to videos. Let me get back. Is that Steve that asked that question?
It is Steve.
Yeah, Steve, let me get back to you on that one in terms of some of the materials that we're working on. We're definitely expanding out the audience and expanding out the tools as well that we have around the NDR. That's the network detection and response tool that we have available. So I'll get back to you on that.
Awesome. Thank you, Larry. And it looks like we have time for one more question here. We have basic monitoring in place. How should we move forward into observability?
Yeah, that's a great question. Thinking back on that evolution chart that we put together, if that's simple monitoring, obviously the next step before going to observability is to really try more comprehensive monitoring. Something like WhatsUp Gold, where you are the total plus version of WhatsUp Gold comes with all of the application monitoring tools, the log monitoring tools. There's many different ways to pull in many different types of data to be able to analyze it and look at those trends. So that's really, I think, a step forward if you're looking to advance your monitoring. Moving more into observability too, it depends on on your budget. It depends on, like I mentioned in the last slide, the questions to ask yourself. Your staff ready? Do you have the budget for it? How do you tiptoe into it? I think that taking a more cautious approach would, and planning it out more carefully through, let's achieve this step. Let's get the comprehensive monitoring set, and then let's expand out and improve how we work with logs, or let's improve how we're doing tracing, or do we have the metrics down, or are some of these tools able to, do we need to interconnect them better through APIs? Sort of taking that stepwise approach rather than saying we're going to do observability and jumping in head first has got to be the way to do it. There's so many cautionary notes. If you were working with an analyst firm, so many of these firms like ESG and EMA and IDC had some great materials out there as well. They're putting a lot of thought into how people move forward from step A to let's say step G on the road to observability. So I would look at the monitoring first and make sure, and like I said early on, your data, making sure the data is accessible and the data can be shared. Those are first big steps.
Awesome. Thank you. Well, that is all the time we have for questions today. If we didn't get to your question, we will make sure to follow up with you directly. Thank you all for joining today's webinar, and we hope you enjoy the rest of your day.
Yeah, thank you so much.